So in this video, we're going to be graphing linear inequalities. So what that means is that we are going to graph an inequality on the coordinate plane. It's got two variables, an x and a y, and you'll see the form of a line that looks similar to maybe slope-intercept or standard form, maybe even point-slope form if you look hard enough. So we're going to start there. In the first example that I have here, it's labeled number 2, we have y is less than 3x minus 1. This is in what we consider slope-intercept form. So y equals mx plus b form. So our slope is 3, which is 3 over 1. So that means we're going to go up 3 and to the right 1. And our y-intercept is negative 1. And that's where we're going to start our plot. So negative 1 is right about here. And then remember, if you look at this, our y-axis, the intervals go by 4. So be really careful, pay attention to that. So we have to go up 3 and write 1 from there. So it's going to look a little skewed, but so 3 is really up here. So it's 1, 2, 3, and over 1. Whoops, sorry about drawing my point there. Okay, so up 3 to the right 1. I'm going to do that again. So 1, 2, 3, and to the right 1. And then up 3 gives me 8, and to the right 1. So I've got a line going there. Let me get rid of that extraneous point. Okay. The other thing that we need to pay attention to, so the first thing that we're going to do is we're going to graph our boundary line. The second thing we're going to do is our line dotted or solid. And that's easy enough. Dotted lines are less than or greater than. Solid lines have the equal sign. Okay, so in this case, no line underneath, not equal to, so we're going to do a dotted line or dashed line. It doesn't really matter as long as it's not solid all the way across. Not equal to, so it's going to be dashed or dotted. The third thing that we're going to do is we have to shade. So are we going to shade above or are we going to shade below? So in this case, it says y is less than. So we want to look at things that are less than our line. In slope-intercept form, it's relatively easy. Less than this line means below. So we should shade below. Before we actually shade, let's do a test point. And you can pick any test point that is in your solution set, because that'll tell us whether or not to shade that part. I'm going to choose the test point. I'm going to make it a different color. 2, 0. So let's test the point 2, 0. Remember, every point has an x and a y. So we're just going to substitute those into our original inequality. So y is less than 3x minus 1. So y is our 0, less than 3 times 2 minus 1. Well, 3 times 2 is 6, minus 1 is 5. Is 0 less than 5? Yes, this is true. Therefore, we can shade below. What we thought we were going to shade is the proper place to shade. Okay, so that's how you figure it out. 3 basic steps. Graph our boundary line, decide if our line is dotted or solid, and then we're going to shade either above or below our line, or to one side or the other. And to do that, you're going to use a test point to verify whether or not you shade. If you chose the wrong side to shade on, your test point would yield a false inequality. Okay, so one more example here. Y is greater than or equal to negative 2 minus 5x. Again, it's kind of slope-intercept form. In this case, our slope is negative 5, which is negative 5 over 1. So down 5 to the right 1. And our y-intercept is negative 2. Let's start with our y-intercept of negative 2. So we've plotted that. Slope tells us to go down 5, 1, 2, 3, 4, 5, and to the right 1. We can also, if the graph is long enough, we can go 1, 2, 3, 4, 5 up and 1 to the right. Okay, so that's our boundary line. So we've graphed our boundary line. Is it solid or is it dotted? Our inequality sign says greater than or equal to, so that tells me that it's a solid line. So our boundary line is a solid line. It's also greater than, so that tells me that I think my solutions are above. So I'm going to shade to the right side of this line. But let's do a test point. I like easy test points, to be honest with you. So I'm going to choose the test point 0, 0. So we're going to test 0, 0. So remember, x is our 0 and y is 0. So y is greater than or equal to negative 2 minus 5 times 0. Well, negative 5 times 0 is 0, so we don't have to worry about that. We have 0 is greater than or equal to negative 2. Is 0 greater than or equal to negative 2? Well, yes, it is. It is greater than negative 2. That's true, so that tells me that I'm going to shade on the right side. Let's just do a test point that's not in our solution set so that you can see what would happen. So let's test, I don't know, negative 2, 0. So we're going to test negative 2, 0. So negative 2 is our x, 0 is our y. Again, we're going to substitute it back into our original inequality. So we get 0 greater than or equal to negative 2 minus 5 times negative 2. Well, the only thing we have to calculate here is negative 2 minus 5 times negative 2, but negative 5 times negative 2 is positive 10. So that gives me 0 is greater than or equal to 8, because negative 2 plus 10 is 8. Is that true? It certainly is not. This is false. So that tells me that I cannot shade on the left side of this graph. I must shade on the right side, because the right side gives us all the true solutions. Easy as that. 3 steps. So graph your line, check your border, is it solid or dotted, and then decide which side you want to shade on. And that's it.